Well, welcome to Brew Builds. I'm Paul. I'm still working on the barbecue and fireplace structure. I need to extend the gas line and connect it to both the barbecue and the fireplace, add in some electrical connections, put on some house wrap, and then I can attach the cement board. You ready? Let's do this. Before I add the house wrap and flashing, I need to work on the gas and electrical connections for the fireplace and barbecue, as well as add a couple of power outlets. I need to do this now while I still have access to run the pipes and wires before I seal everything up. Tools and items needed. Assortment of black pipe fittings, pipe thread sealant, pipe wrenches, leak detector, a gas pressure test gauge, gas shutoff valves, electrical junction box, outlet boxes, 14 gauge and 12 gauge wire, wire nuts and cable clamps, wire cutters and strippers, screwdrivers or a screw gun, electrical tape, a pair of pliers, waterproof receptacles, an outlet tester, house wrap, a utility knife, a pair of scissors, aluminum flashing, tin snips, high temperature duct tape sealer, and some construction glue. The gas and electrical line runs from the house under the pavers out to the fireplace and barbecue. I ran these lines underground before I poured the slab for the fireplace, so be sure to check out that video. On the brew scale, technical ability I rate as an expert. You need a good understanding of gas fittings and electrical connections. Physical ability I rate as difficult. You may find yourself working in awkward positions. And remember, gas and electricity can be dangerous. Most important thing to do before working is to shut off the gas. Fortunately, there's a shutoff valve in the attic for this branch of the gas line that goes to the fireplace and barbecue. Okay, disclaimer time. Because I'm not a licensed professional, I'm a bit cautious about making videos of my DIY projects that deal with gas and electricity. Both can be simple, but also dangerous, so hire a professional if you're unsure. I do my best to do things correctly, but I'm sure there's a better way. My main goal is to show you what it takes to do these types of projects yourself. Hopefully you gain a little bit of knowledge and you can make a wise choice if you want to tackle it or hire a professional. If you do choose to do your own work, and it's legal in the state for you to do it, make sure you follow your local building codes and you have your work inspected. If you don't know how to do that, hire the professional. I need to remove the old gas valve and quick disconnect for the barbecue, then rotate this elbow so it faces towards the back. When working with black pipe, you shouldn't just tighten or loosen the fitting because this can break the seal. It's best to remove it, clean up the threads, and add new sealant. I'm using this number 5 pipe thread sealant on all the black pipe fittings. I prefer using this over the yellow Teflon tape. For me, I just get a better result when it comes to a joint not having a leak. Apply enough sealant to cover all the threads of the pipe. The directions state for pipes with a diameter up to 1 1/4 inches apply to the male threads only. Black pipe threads are tapered. The more you screw it in, the tighter it will get. To make a good seal, you want to be able to get 3 to 4 rotations by hand, then another 2 with a pipe wrench. This is starting to get tight, and it is just about facing in the direction I need it. I don't think I can get another full rotation without a whole lot of force. I'm running the black pipe through the cutouts in the metal studs, and then we'll add a 3/4 inch T to install a debris collector, which isn't required by code in my area, but I thought it would be a good idea to have one. I'll attach the next elbow to a 5-inch nipple first, coating the threads evenly, then tightening the joint. It's best to tighten each joint individually using 2 pipe wrenches. When connecting to an existing pipe in your home, be sure to use 2 pipe wrenches so you can hold the existing pipe to prevent it from twisting. Because if the pipe you're connecting to ends up turning, it can twist the joint and break a seal, causing a leak further up the line. I know I didn't use 2 pipe wrenches when I attached the first elbow, but that was attaching it to a riser which doesn't have any other joints that could have twisted. Once you have it tight, you can wipe away any excess pipe sealant. At this end I have the first tee for the debris catcher. Then up from there will be another tee, but this one will also reduce from 3/4 inch to 1/2 inch pipes, so I can add the 2 gas shutoff valves for the fireplace and barbecue. I will do a dry fit first, remove it, then assemble it out from under the barbecue where I have more working space. Another way to check if you're tightening your joints enough is to look at the number of threads remaining. A pipe end should have 10 to 11 threads. If you're tightening a joint with 6 to 7 rotations, you should have 3 to 4 threads remaining. If you see 7 threads remaining, it's not tight enough. I will need to do both ends of this short 1-inch nipple at the same time. The nipple is too small to get a pipe wrench around it without damaging the threads. This is a good situation where you might want to count the threads to make sure that both ends are tight enough when you're done. Once I get this screwed onto the pipe in the frame, then I'll attach the shutoff valves. Natural gas pressure in your home is very low at about 1/4 psi. Gas shutoff valves have numbers and markings on them showing you what pressure the valve is rated for. A gas shutoff valve must have a 1/2 G rating, which is the low pressure gas rating. There also may be a 5 G rating, which is a slightly higher pressure rating, and you might see a 600 WOG label, which is 600 psi for water, oil, and gas. This yellow one doesn't have the 5G or the 600 WOG markings on it. This is where it can get confusing about what to do for a pressure test. Since some gas shutoff valves only have the 1/2 G low pressure rating, which is around 2 psi, my understanding is you're required to remove all valves and put a cap in place when doing a pressure test. While you may not damage a valve, the issue is damaging a pressure regulator in an appliance past the valve if it fails, or more likely if the valve is accidentally opened or knocked during your pressure test. I disconnected this line from the shutoff valve in the attic. That way there's no chance of high pressure feeding back into the main gas line for the house. Fortunately, there was a union I could disassemble, then cap this line off for the test. However, I'm going to leave these valves in place since they're not connected to any appliances. Because of the lack of clearance, I'll use the yellow valve in the open position to attach the test pressure gauge using a piece of flex hose, and the higher rated red valve will be in the shutoff position. Hopefully this won't be an issue. I probably should replace this old yellow valve with one that has a higher rating when I'm ready to finally connect the barbecue. I'll add about 10 psi. The valve stem pin is too long on this test gauge, which makes it tricky to get air into the system. Now I can apply leak detector to all the joints. Well, I found a leak at the test gauge. I guess my plastic irrigation adapter didn't get a good seal. This is what a leak will look like when you're using this type of leak detection fluid. I reapplied the Teflon tape on the adapter that was leaking and took the glass cover off the test gauge because the needle was getting caught on this glass cover. So far, all my failure points have been with the test gauge. I fixed the one leak at the test gauge and I didn't see anything else leaking, so I've taken the pressure up to the required 15 psi for new gas lines. I still don't see any bubbles or leaks, but I'm getting a very slow pressure drop. I'll keep searching. I found a small leak at the union in the attic. Maybe it moved when I loosened the nut. I took both sides apart, cleaned the threads, reapplied more sealant, and tightened the joints. No bubbles, seal looks good. So the question is, was it leaking before, or did I cause it to leak? Which brings me to the gas meter and how to check if you might have a gas leak at your house. Since most appliances have switched from pilot lights to electronic igniters, there really shouldn't be any gas flowing when your appliances are off. Looking at the dials, you can see if there is any gas flowing. I turned on our hot water so you can see the dials moving. This dial here represents the smallest amount. For every revolution this dial makes, this one will move a bit. And for every revolution this one makes, another one will move, and so on and so on. If you don't see any dials spinning, take a picture with your phone and then come back in 15 minutes and check to see if the dials match the picture or if they have moved. If they have moved, it means either that an appliance turned on, or you have a pilot light somewhere, or you may have a gas leak that should get checked into. Another good thing to know about a gas meter is how to turn off the gas in case of emergency. In this situation, this is the outlet going into the house. This is the inlet coming in from the street. So to shut off the gas to this meter is this valve right down here. All right, the gas is finished. Time to start working on the electrical. To protect the wires, I'm using these plastic inserts that go into the holes of the metal frames. They go on each side of the stud, through a hole, and then snap together. Then I can run the cable for the fireplace and the wiring for the two outlets through these protective inserts. These plastic electrical boxes I'm using have a screw so I can adjust how deep the box will set into the wall. That way I can adjust the depth to the cement board and stucco. I did need to add another stud and a piece of track to get these boxes positioned at the correct spot. I installed a temporary outlet for the barbecue so I can use it during construction that ties into the load side of a GFCI receptacle. I'm replacing this plastic junction box with this metal junction box that has more holes for wires. Pushing the test button will shut off the power to this outlet and anything downline of it. If you don't have a GFCI, which is required by code for any outdoor receptacles, turn off the power with the circuit breaker that feeds the circuit you are working on. Now I can safely remove the receptacle and replace this junction box. I'm also going to pull out all the wires out of this conduit so I can add in 2 more circuits for lighting. Originally, I ran Romex or NM cable for lighting, but this is not to code and will need to be replaced. NM cable is not allowed in wet locations. I found out the underground conduit is considered to be a wet location. I'll attach the cable clamps to the box first, then mount it to the stud. I need a clamp for the fireplace power cable, the outlets above the barbecue counter, and a lighting circuit for some lights. The barbecue has a plug, so it will use a receptacle. When I pulled the wires out, I attached a 12 gauge wire to them that I can use as a pull wire. I also added some conduit from this box up to the old patio light so I can connect to the old lighting circuit. Using electrical tape, I attached the 12 gauge wires for power and then 2 sets of 14 gauge wires for lighting to the pull wire. They all have the THNN and THWN rating, which is needed if the conduit is buried in the ground. With 2 people, the wires pulled through the conduit easily. I just needed an extra hand, so I wasn't able to get it on camera. Now I'll insert the pull wire into the upper conduit so I can pull the wires for lighting up to this junction box. There it is. Let's see if I could do this without getting a tangled mess. I'll push it up as far as I can. Then pull on the pull wire. And push it up again. And pull on the pull wire. I'm going to need to use 2 hands again to get this tucked into the box. Now I can wire the GFCI receptacle back up. Make sure you wire these properly or they won't do their job. The line side is for the power coming into the receptacle, and the load side is for the outlets downline that you want to have the GFCI protection. There are places to attach the wires that loop through but are not protected, so don't connect any outdoor receptacles to those. This one has a slot that the wire inserts into. Then you tighten the screw down to hold the wire. Just make sure the wire is fully inserted. Black or hot wires attach to the brass screws, and white or neutral wires attach to the silver screws. The ground wire attaches to the green or brass screw at the bottom of the receptacle. I already attached a short pigtail for the ground because I'll be using one of these Wago lever nut wire connectors. Now to squeeze it all back into the box. This waterproof cover is held on with the same screws as the receptacle, so I just need to get the screws started, then slip the cover over the screws, then tighten it down. One of the code requirements you need to be made aware of is how many wires you're allowed to put in an electrical box. Every electrical box will have a marking on it showing you the volume of the box itself. This box here has a volume of 30.5 cubic inches. Each wire, switch or outlet, and even clamp take up space in the box, and you're only allowed to take up the space that's listed on the box. To calculate this, you add up everything that's going into the box. Each wire, hot or neutral, count as 1 unit. An outlet or a switch will count as 2 units, and an internal clamp will count as 1 unit. All of the grounds together count as 1 unit. Then you multiply that number by a volume multiplier. 14 gauge has a 2.0 and 12 gauge has a 2.25 fill volume multiplier. For example, in the box under the barbecue, I have the 6 12 gauge wires for power. Then there's the 6 14 gauge wires for lighting. Then there's the 2 receptacles. And then all the ground wires. No internal clamps. Adding everything together, I get 17. Then multiply 17 by 2.25. We get a box volume requirement of 38.25. There are some box fill calculators online that are available that do the math for you. This is just a quick tutorial. I recommend researching this more if you will be doing your own wiring. This 30 cubic inch box is too small, so I'll be adding a box extension to it to increase the volume by 17 cubic inches, to bring the total to 47, which is well beyond the 38.25 required. This single box is still okay because I don't have to count the wires that are not connected. But when I do connect this extra lighting circuit, I will have to upgrade this box, but that'll happen when we start remodeling the kitchen. To wire the junction box, the first thing I'll do is attach pigtails to the receptacles. I want the lighting receptacle to be connected to 2 different switches, so I'll break off the connecting tabs in between the screws. I bent to 180 at the end of the pigtails. This will wrap around the screws. I like to wrap the wire so when you tighten the screw, the screw will pull the wire into itself instead of pushing it away. In other words, the open end of the wire should be on the right side of the screw. Again, the black or hot wire goes to the brass, white or neutral goes to the silver, and the green or ground goes to the single screw by itself. Make sure the bare wire is resting flat under the screw and not on any of the plastic part of the receptacle. The wire insulation should go up to the screw but not under the screw, and you don't want to see any bare wire showing past the outlet or switch body. Also, it's a good practice to tighten any unused screws. I'll attach the two receptacles to the extension ring, then organize and prepare the rest of the wiring. I still need to strip the power feed to the outlets above the counter. This is 12-2 UF cable. It's like NM cable, but has a much tougher protective jacket and is rated for outdoor use. This jacket is harder to strip off compared to Romex or NM cable. Because of this, I find it easier to accidentally slice the individual wire insulation itself, so be careful and go slow. Bend it back and forth, slicing both sides. Eventually, you should be able to pull the jacket off. I already have one ground wire attached to the box in the upper right. I'm going to attach another one to the ground screw in the upper left. I'll be using some push-in wire nuts for the first time on this junction box. Starting with the 14 gauge lighting circuits, the power for the switch that will turn on the lights above the barbecue will be attached to the circuit that goes to the upper part of the receptacle, and the spare lighting circuit will go to the bottom. All the hot, neutral, and ground power wires need to be tied together. I had a difficult time getting the stranded wires for the fireplace power into the push type wire nut, so I switched those out for the lever type wire connector. These push-in type wire nuts are much easier to use than your standard twist wire nut. However, I found a disadvantage to them. It would have been better if I purchased the 4-hole version. Since I only have the 3-hole version, I'll have to make jumpers to tie all the wires together. I'm sure there's a variety pack out there that has all the different sizes needed for these push-in connectors. Now to attach the receptacles. The hot and neutral for the spare lighting circuit, the hot, neutral, and ground for the power circuit, and the upper lighting circuit with the line to the switch. Oh, I'm short a spot for ground, so I'm going to go old school and use a wire nut so I can connect 4 wires together. When using wire nuts, check that each wire is in the nut and tight. Time to attach the extension ring to the box. Make sure all the wires are fitting nicely in the box, then tighten the screws. Turn on the breaker or reset the GFCI receptacle and check that everything is wired properly. And now for the lighting circuit. And it's not turning on. Oh, oops! I guess I need to connect the wires in the lighting junction box on the wall. I'm keeping these long for future changes, and I'll use a lever wire nut so it'll be easy to modify later. Now it works. I just need to attach the junction box cover, then it's on to the house wrap. I'm curious to how watertight this stuff actually is, so I set up this little experiment here with these blocks and some of these house wrap material, and I'm going to puddle up some water here and see how long it takes to drain through, if it will drain through. While I'm waiting to see what happens, I'll start cutting some pieces and attaching it to the framing. Since I'm attaching this to metal studs, I can't use staples, so I'm using some construction glue to hold this on until I'm able to attach the concrete board. I also have some of the joint tape by Typar to help seal all the pieces together. My goal is to have the moisture or water run down the sides of the fireplace, across the countertop or seating area, then down the side of the structure and drain out the bottom. Unless you have a flat surface so you can cut the moisture barrier on, I found using a pair of scissors works better than a utility knife. I realized when I started adding some of the moisture barrier, I needed a few more supports for the cement board to attach to. Good reason why you shouldn't throw any usable scraps away until you are finished. After checking on my experiment with the moisture barrier, I learned that water will not penetrate this stuff, which is good, but I need to correct something. I'm going to add a 1/4 inch piece of hardy board under the moisture barrier for the seating area. That way the moisture barrier will lay flat, which will prevent water from puddling in a low spot if it gets into this area somehow. When applying a moisture barrier or any other type of flashing, you start at the bottom and work your way up the wall. Now, part of the reason why I wanted to apply a house wrap to this project is because we're planning a major kitchen remodel, and I've never used this stuff before, and I'm probably going to have to use some. So I thought this would give me a good chance to learn something new. This is becoming quite the patchwork, but it should keep the moisture out. I also need to add some aluminum flashing around the fireplace. This requires non-combustible material to be used above and on the sides of the fireplace, and since it's also outdoors, it needs to shed water properly, so I'll be adding this all around this area. Use a utility knife to score the aluminum flashing, then bending it will break it off at the line. Use a pair of tin snips if you need to make a curved cut. I'm attaching the flashing using a Flex Fix Class 1 duct tape sealer. It has a bonding rating for 212 degrees. there will be a concrete mantle above the fireplace. To hold the weight of the mantle, I'll add some 3/8" bolts to the metal stud that I can use to attach the mantle mount to the wall. While I'm here, I need to test one more thing.
I created fire. Fire.
To seal around the post, I'm using some window flashing. I'll cut some 2" strips that will stick to the post and a 4" piece that will sandwich the house wrap up against the post. To cut openings for doors, use a sharp utility knife and cut about 3 inches away from the edge. That way you can wrap and tape the material to the inside of the door opening. These orange marks are placed every 8 inches, which makes it easy to cut the length without using a tape measure. Now that the structure is wrapped and watertight, I can start attaching the cement boards. But that will have to happen in the next video. I thought it would all fit in this one, but there was just too much to cover. Thanks for watching and hit the like button. Be sure to subscribe and turn on notifications so you will know when I upload a new video. I have all the studs marked on the house wrap. Let's get these boards installed.